Hello Creo Parametric users, my name is Sudhanva Puranik. I am a trainer for Tata Technologies and a Creo content developer for iGetIt. In the iGetIt tool, I am creating the courses for PTC Creo. Welcome to the live session on the topic how to create a family table and how to create a multi-level family table in Creo Parametric 10.0. In this session, I will cover the topics as follows. Understanding the bolt model, which is having pre-configured relations. Then creation of a bolt model family table with 3 different types of bolt head instances, and creation of a multi-level family table for one of the bolt family table instance. So in the first task regarding the understanding of bolt model having pre-configured relations, each feature of the bolt model is having renamed parameters, and all those renamed parameters, they have been assigned with suitable types of relations like this. Then as a second topic, creation of bolt model family table with 3 different types of bolt head instances. So there are 3 types of extruded cut features available in the generic instance of bolt model like this. And then we will create 3 family table instances which will be created for the bolt model, and those will show the 3 types of cuts created on the bolt head, like hexagonal cut, a cross shaped cut, and a rectangular shaped cut. This type of family table we will create, and over there for each types of instance we will create different dimensions as well. Then in the third task, we will create a multi-level family table for one of the bolt family table instance. So this is the top level table of bolt family table, and here for the hex bolt instance we are creating a instance level or multi-level family table, wherein there is a bolt dia parameter in the bolt model, and that is linked with a relation to the bolt size 1 parameter, and based on this parameter and 2 features, I will create a instance level family table for the hex bolt instance of the main family table. So these topics I will show one by one in this live session, and we will be covering such sessions further as well for different CAD softwares like Creo, CATIA, NX, and so on. And for more information, please visit our website, that is myigetit.com, wherein you will find interesting courses on different CAD softwares. So thank you for attending this session, and let us move to the current topic, that is first about creating the family table for the bolt.prt. So in this model, let me go to the revolve feature and edit. So initially you will see the dimensions of that bolt, and if I click on switch dimension, then you can see the main dimensions, they have been renamed like bolt diameter, head thickness, and shank length. Then if you look at the second feature, extrude 1, that is having one parameter, one dimension renamed as base thickness. Then the round feature, that has been renamed as R for the radius. In the hexagonal shape cut, there is a hex depth renamed dimension available. In the cross shaped cut, there is a CW1 and CW2. These are cross width 1 and cross width 2. Those 2 dimensions have been renamed, and there is one more dimension, cross depth. And for rectangular cut, there is a RW, rectangular width dimension, plus the rectangular depth dimensions. These have been renamed. Then if you look at these relations, so for all of those parameters that I renamed in the features, I have given the simple algebraic formulas like base thickness equal to head thickness divided by 3, radius equal to bolt diameter divided by 4 minus 2, hex depth equal to head thickness divided by 2, cross depth equal to hex depth, rect depth equal to hex depth, CW1 equal to head thickness divided by 5, CW2 equal to CW1, and RW equal to CW1. So these types of relations I have given for all the parameters coming out of these all features over here. So this is the pre-configured relations in the model, and now let me begin with the family table creation. So I go for family table option from the tools tab of ribbon. Then let me first go for the add delete table columns command, and here I need to add the parameters. So first I want to add the dimension parameters. So I will go one by one: bolt dia, then head dia, then head thickness and shank length. These are 4 dimension parameters. Then I go for the feature, and in the feature I select the cutouts: hex, cross and rectangle. So these many things I want in the family table. Let me say done and click OK. So you can see the family table that is populated with the initial list of parameters that I selected. Now, as I want 3 instances which will represent the hexagonal cut, cross-shaped cut and rectangular cut. So here in the rows I will add 1, 2 and 3. These 3 rows I will add, and I will rename the instance file names as per my need. So I would say this first instance name as bolt hex head, hex cut head. That is the name I will give to this thing. Then second instance I would say bolt cross cut head, and third one to be bolt rect cut head. So these are the 3 particular names I have given for the sake of identification. Now the dimensions I need to populate. So the 4 dimensions: bolt diameter, head thickness and shank length. I can have multiple values so that for each instance the dimensions would be varying. So I have those list of dimensions. First is for hex: 40, 80, 25 and 150. So let me go for that: 40, 80, 25 and 150. So here I go for 40, 80, then 25 and 150. This is 25 and this is 150. So these 4 are the dimensions. Plus I am saying that this is the bolt with hexagonal cut. So for the hex feature only I would say yes, and for remaining 2 cuts, cross and rectangle, I would say no for them. Then next is 30, 55, 20 and 90. So 30, 55, 20 and 90. These are the dimensions: 30, 55, 20 and 90. 30, 55, 20 and 90, and it is a cross shaped cut for the head. So cross, let me say yes for the cross cutout, and the remaining cutouts I would say no. Then for the bolt rectangular cut head, for this the dimensions are 25, 45, 12 and 50. 25, 45, 12 and 50. This is 25, this is 45, this is 12 and this is 50. These are the dimensions, and this instance is having rectangular cut head. So for rectangle cut I would say yes, and for remaining 2 cuts I would say no. This way I have populated the family table, and I need to verify whatever values I have used for these all instances of the family table. Are they coming well? Will they create the bolts as per my specifications that I have given over here that I need to check? So I would click on this verify instance. They are unverified. Let me click on verify, and the success is shown over there, which means that all of them will be created well. So let me close this. Let me say OK for the family table, and I will just close this bolt part, but I will not erase that from the session memory. So let me open that bolt part again, and now you will see that it is now showing me the generic instance that I was having initially plus the 3 instances that I created. So first is bolt hex cut head. If I open that, you can see only the hexagonal cut is available, and the revolve feature that will show the dimensions 20, this 40, 80, 25 and 150. These dimensions are being shown for this particular instance, and the name is bolt hex cut head. That is the instance name. Again, if I go for the bolt opening, and this time I would go for cross cut head. So here only the cross shaped cut is shown, and the dimensions they are 90, 30, 20 and 55. Further, if I go for again opening the bolt, and this time the rectangular cut head, so this will show only the rectangular shaped cut for the instance, and the dimensions they will be like this 25, 45 or 12 and 50. So this is a very handy tool, the family table, wherein for any part which is used multiple times, which is a generic part which is commonly used in the assemblies, so we can create different instances and we can call them quickly and we can use them in the assemblies. That is the use of family table creation. So now let me close all these parts and let's move to the next topic, that is about the multi-level family table. So let me open this multilevel.prt, and I will open the generic instance only, and here you can see the 3 same instances, hex bolt, rect bolt and cross bolt. So the same table will be available over there that I used and that I have shown you in the earlier topic of this session. So this is there, and there are some more things added over here. If you look at the relations, before that let me show you the family table. Family table is having the only the instances with the features, only the rectangle, hex and cross, but there are no dimension variations. So dimensions I haven't added over here, only the yes and no for the 3 features, rectangle, hex and cross. Then if you look at the parameters, there is one parameter available, bolt size, and it is an integer type parameter. Value is 14 right now. Then if you look at the relations, that bolt size 1, so bolt diameter is equated to bolt size 1 plus 2. So bolt size 1 parameter current value is 14. That's why the bolt diameter value would be 16, because it is equated to bolt size 1 plus 2. That is the current formula available over here. Plus there are 2 more features. There is one chamfer added over here and one hole added over here. These 2 are the additional features as compared to the previous example. So I go for family table and I have my first instance of hex bolt. Let me select this and then I go for insert and instance level table. So here now I need to first configure the table columns. So I will go for columns, and here first I will go for parameter. Now I have one parameter, bolt size 1. I select that and I click on insert selected. So that parameter gets listed over here. And then in the features, I add the chamfer feature and hole feature, these 2. So these are my table columns. Then let me add 4 rows over here, 1, 2, 3 and 4. So when the bolt size 1 parameter is 14, the bolt diameter is +2, that is 16. So let me add the values like 15, 20, 35 and 50, or rather this I would say 48. Let me say this adds 19. Let me say this adds 23. I would say this adds 33. So I would deal with the instance file name. The common name I can keep as it is. So for the diameter, let me say this as 18, bolt size 1 parameter. So for 18 bolt size, the bolt diameter would be 18 plus 2, that is 20. So here let me say diameter value as 20 for the bolt diameter, and let me say hole chamfer as the name. So what I need to have, that the diameter of bolt is 20 plus there will be hole and chamfer both. So I would say yes for hole and chamfer both. Then this is 23, means bolt dia would be 25. So here I say 25 and I would say here as no hole and no chamfer. That is the name for second instance. And here I would go for no for both the features, chamfer and hole. Then here 33 means diameter would be 35. So 35 and I would say no hole but chamfer, means chamfer is yes. So here I would say yes for chamfer but no for the hole. And finally this one, diameter would be 50 and here I would say hole no chamfer. So chamfer I will say no and hole I will say yes. This way I have created the family table. Again I need to verify. So let me click on this verify, and now see, the multi-level is the main part and it is having 3 instances: hex bolt, rect bolt and cross bolt. The hex bolt has been success, rect bolt and cross bolt they are also having success, but the hex bolt instance level family table, that is unverified. Let me click on verify and they are having success. So now everything is having success. Just close it and click OK. Now again if you click on the family table, you can see that the hex bolt is having a folder icon, which means that it is having one instance level family table, and you can find that family table over here. You can access it from here. You can further modify if you want. That way the listing is done for the instance level or multi-level family table. So now if I close this model, but I will not erase it from the memory, then I go for opening the multilevel.prt. So here I'm having the hex bolt. I click on open. Again it goes for the instances. So if I open this hex bolt 35 no hole chamfer. So now see the diameter, that is 35. It is no hole chamfer. So chamfer is there but there is no hole. Then again I go for multi-level. I go for hex bolt and this time I go for hole and no chamfer. So here there is the hole present but chamfer is not present, and the diameter value is 50. That was coming through the bolt size 1 parameter. Then again I go for opening, and if I open this, no hole no chamfer with 25 diameter. Now say there is no hole and no chamfer, both features are not there, and diameter of the hole is 25. This way we can create a instance level or multi-level family table in Creo Parametric 10.0. So here I conclude the session. and hope that you all have understood the topic well, and I have added some useful insights to your Creo parametric knowledge base. So further, I need to request you all that in our I Get It, there are multiple libraries available for different CAD softwares wherein you can find the courses like 3D Experience or AutoCAD or some automotive domain as well. Then CATIA V6, CATIA V5, PTC Creo, for which I have shown you the topic right now. They're on plastics domain, on PLM, etc. So please go through the I Get It website, that is www.myigetit.com, and try to find the courses over there. Try to purchase those courses and try to increase your knowledge base for your CAD software that is your favorite. So let me show you the catalog of PTC Creo that right now we are discussing. So in PTC Creo, we are having different versions courses: PTC Creo 2, 3, 4, 6 and 10. 10 is the recent version. So for PTC Creo 10, which is the recent version, we are having multiple courses right from what's new, CAD updates, then basic essentials, and right now I'm doing the course on advanced modeling that will be released soon. And further 3 more courses will be released soon on advanced aspects of Creo by the month of March in next year. So please go through our I Get It libraries and try to subscribe, try to purchase the courses. Also, if you go to YouTube, then there is one web page, that is I Get It Learning for engineers. Here there are different playlists. For example, Siemens PLM NX, PTC Creo, Inventor, GD&T, 3D Experience CATIA, Autodesk Inventor, and so on. So here we are listing our tech tips videos and live webinar videos. So for example, the PTC Creo list here, you can find my all videos that I created in past for the tech tips and webinars. So you can go through them as well. So I request you all to take most advantage out of our I Get It, and I request you all to purchase our courses. So thank you for attending this session. Thanks a lot.